Positively Perfect Problem Solving presents Continuous Relations and Functions. Last learning target, we talked about discrete relations and functions, those graphs that are made up of independent points. So today we're going to talk about continuous relations. So continuous relationships is a graph of relation made up of those dots that are all connected lines, or they look like curves. We call this continuous, which kind of makes sense. Okay, so this is a continuous graph because everything is connected as like one single line kind of curvy thing that this shape is. Versus this other graph that we learned last learning target, this is a discrete graph. They kind of look very similar in terms of the points are kind of in the distinct points from the same places here, but the continuous graph includes all the points in between those points, right? Like I could pick this spot on the graph and that's a point along the graph. I could pick here, that's a point along the graph. So we have a lot more points along this graph than we would in a discrete graph. So today's learning target is really talking about domain and range of these continuous graphs. Review a second on domain and range of a discrete graph. So last learning target that we talked about finding domain and range of a discrete, we use something called set notation. Okay, and if you remember, the domain is all of your x values. So we're looking for all those values of x. So when I look at this graph and I look at this point, its x value is 1. So I've got 1 as my first. Then I have 2. This third point, the x value is 3. The fourth x value is 4. And all I'm doing is I'm taking that point and seeing where it lines up with the x. So that's kind of in my mind, that's how I'm visualizing this. Then I see 4. That right there is on the 5. And then this guy right here is all the way on the 6. So this domain is the set of values. The range, on the other hand, and we'll do the range in green, are all your y values. So y values, I'm going to go ahead and erase the red part here. The y values is just now going the other way towards the y-axis. So this one goes with -1, and I always start with the lowest. I always start with the bottom and work my way to the top. This y value is at 0. This one is at 1. This one is at 2, this one is at 3, and this top one is all the way up at 6. Another way I taught you guys this last learning target was to write all of the coordinates and then look at your x's and y's. That's totally another way you can do it to find these points. And the more practice you do with this, the less of these little tools you'll need. But for now, I've shown you a couple tools to find these points, so hopefully on your work I can see those tools in action to help you. Okay. Now, another really important part of domain and range is being able to read it and speak it out loud. That's really critical. So with a discrete graph, when I ask you what is the domain and you have to say something out loud for a discrete graph, remember a domain is all of the possibilities of points. So the domain in this case is only the set of, that's really important using the word set of because we're using set notation, the set of values 1, 2, 3, 4, 5, and 6. That's how we'd say this out loud. It's also how we'd read it. Range is very similar. We would say the range is only the set of values -1, 0, 1, 2, 3, and 6. So this is how we'd speak this and say that. Okay, and on a test or a quiz or mastery, I might ask you a question on how you'd write this out in English. Speaking math is really going to help you learn math better. Okay, so this is kind of review from what we did last learning target. So now we're going to talk about how we find domain and range of a continuous graph. which is a very different type of thinking. And I'll show you what I mean. When the graph is continuous, we no longer use set notation. We no longer use those squiggly brackets. For domain range of continuous functions, we actually have two ways we can write this. So the first way we can write it is called interval notation. And I'm going to talk about that one first in this problem. So here's a continuous graph, right? All these points are connected. I do want to point out that it's in the same shape as the one we just did to kind of help us see that while some of the points are the same, we do have to talk about it a little differently. So I have a couple problems with this one. I can't just look at this and find specific coordinate pairs. This is the problem. Right? There are a bunch of points. I know you can kind of see the original points, but like I said before, there are points in between. Like, look at all of these points in between here, right? And technically there are infinite points in between here. There's decimals, there's fractions, there's a lot of stuff going on. And I'm just kind of putting dots to show you that there's lots and lots and lots of points. It's impossible for us to write down every single possible point. So we have to figure out another way to describe all of the possibilities for this graph. So when we talk about the range and the domain, we're actually talking about where the domain starts and where the domain finishes. So when we describe it, we can say, look, it starts here, it ends here, it includes all the points in between. So interval notation is picking your starting value and picking your last value. That's what it's going to show. So domain, when I think of domain as being the left to right, which kind of makes sense because remember, domain is your x values. And do you see how the x-axis is from left to right? So when I think of domain, I always want to think of my farthest left point. So I kind of take my hands and I do like this with my hands. I'm looking for that farthest left point to the left and the farthest left point to the right. And when I look at this graph, this guy right here is my farthest left point, and this guy right here is my farthest right point. Okay? So I've determined that those are my left and my right points. Now I ask myself, because domain is x, I say, okay, what is the x value of this point? The x value of this point is 1. So the farthest left point is 1. The farthest right point, I'm connecting to the x-axis, is a 6. So I write 1, 6. Then interval notation is where we pick brackets. So this is interval notation. These two things are interval notation. And I have to pick brackets or parentheses. So remember how inequalities that you guys did? That's not your bell. That's just the bell while I'm recording. In inequalities, I told you guys to use brackets or parentheses. That's where this comes into play. These 2 points are closed circles. So we need to use brackets on either side of this to show that the 1 is included and the 6 is included. Okay, I don't have an open circle on these 2 things, and you'll see examples later that do, but these are closed circles, right? If I erase that, you're going to see that that point is a closed circle. So I do 1, 6, and that is saying that I start at 1 and go to 6, and I include all of the values in between. So that's one way we can notate domain and range. Sorry, domain using interval notation. To work on range, this is interval notation here. Okay. Now we got to think about range. Range, you have to turn your brain around. What I mean by this is now with range, you're looking at your y values, and instead of left to right, you're looking from bottom to the top. So I think of it like this. Here's my lowest point right here. Here's a highest point. So now I'm asking myself what's the lowest point? It reaches down here, and what's the highest point? It reaches up here. Well, this guy right there is my highest point, and this guy right here is my lowest point. So I found the highest and lowest. And now what I have to do with that highest and lowest is now connect it to the y-axis to figure out what those points are. So with the purple, my lowest point is -1. So I'm going to write -1. That's my lowest point of the y's. My highest point of the y's is a 6. So I'm going to put -1, comma 6. And because these are closed circles, I use the brackets to describe that. Okay. So notation's the same for domain and range. We're just having to kind of twist our minds from left to right and then twist our minds from bottom to top, which can be really, really challenging for your brain to do. Okay. So that's one way we can do domain and range and interval notation. The other notation that we have to know, because this is going to come up in Algebra 2 a lot, is called inequality notation. And let me get my color up here. So inequality notation is the other way we do this. And you surprisingly did this in the last unit. I promise I don't teach you guys things that won't come up later. I don't want to waste your time. So inequality notation looks very much like lesson 3.4. Remember in lesson 3.4 we kind of also had those like we had graphs that kind of looked like this, and then you do things like make a line and then make an arrow, like a parenthesis and a bracket here. Those are what your graphs look like. See how this is kind of like interval notation with the parentheses and bracket, but when you wrote it out, you'd put an X, a less than sign, and then something went here and something went here. That same idea is exactly what inequality notation is. This guy that you did before in unit 3.4 is exactly inequality notation. So now we're going to apply that to domain and range. So all you need to do for domain and range to make this notation work is we're going to since domain is x's, we're going to put x in the middle. Because we're using brackets, that goes with a greater, less than or equal to, and the less than or equal to, we have to put the bars. And then all you have to do is put the low number on the left and the high number on the right. Okay? So I'm putting the word or because either of these notations totally work, and we can use either one to describe the domain. Going forward, I want you guys to use both notations throughout your practice to get used to seeing these in the same way. Range is exactly the same thing, except one really important difference. We're not looking for x's with the domain, we're now looking with y's. So we're going to put the y in the middle, keep the less than or equal to because we have brackets, and then just put your smaller number on the left and your bigger number on the right. And remember in the last learning target with 3.4, we were saying this means that y is between these two values. So that leads me to the next part of how we actually word these two things. How do we say these things out loud to describe all of this crazy notation? So in continuous functions, to say the answer out loud or to read it out loud, I'm going to now say the domain is now all values. It's all the values we can think about instead of just a set of. It's all values between, actually let's use the word between. We're going to say all values from 1 to 6, because using the word from says that 1 is included and 6 is included, which we really need because we're using brackets. Range is the same thing, only we're using the different numbers. We're saying range is all values from -1 to 6. So this is a lot of information I gave you. I think this is entirely new for a lot of you, which is great. I want you guys learning new things and I want you challenging yourself. This is definitely something that it's a higher algebra topic. So if it's challenging, that's okay. I want you guys to be challenged. I'm going to add one more thing on your notes so you have it. This guy and this guy, that's your inequality notation. So I just want you to have that to look back on. So you have all this. So that's inequality notation. Okay? Let's look at a couple more examples where I'm actually going to use that part of we don't want to include, and we're actually going to use parentheses in the next couple examples. So I've got 3 more examples to show you here in this part of the lesson. So I've got 3 new graphs. Notice they're all continuous. right? There's no distinct points spread out. All of them are connected. I do have these weird open circles, and I'm kind of going to describe what that means here. So let's go ahead and do domain first of this problem. I think left to right. So in my mind, I usually like draw these two lines on the left and the right, and I ask myself, what is the farthest left point? My farthest left point is this, and when I draw dots to the x-axis, that gives me 1, 2, 3, 4, 5, 6, 7. And since it's left, it's actually -7. It's a closed circle, so it's going to be a bracket and then -7 as my first value on the left. On the right, I'm going to drop my dot down to the x value here, and that's 1, 2, 3, 4, 5. So the farthest right point is a 5. I'll write the x's here. And because this is an open circle, that's where the parentheses comes in. I know this looks really weird, this bracket parentheses thing, but that is the correct notation. Now when I do my inequality notation, I put that x in the middle, I put my less than signs. Because -7 is a bracket, I need to put a line under here. 5 is a parenthesis, so I'm going to leave the line off, and then just put -7 here and 5 here. I'm going to put the word or to show that either of these work. So that notation or that notation. Now I'm going to do my y. I'm going to erase the red, and then I'm going to go ahead and look for my very lowest point and my very highest point. So I'm going to draw my line here. There's my lowest, there's my highest. My y value then here, I'm going to make dots that go to the y-axis, and then I'm going to count where that is. That's 1, 2, 3. So that's -3 as my first y value. And then my top y value is, oops, wrong way. See, I drew it to the x. You need to draw it to the y. So dot, 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 dot to the y. And that's going to be a value of 1 on the y-axis. This is a closed circle, so bracket here, and then open circle over here on the 1. Go ahead and put it in inequality notation, and it's going to look like this. So there's my domain and range for this problem. For the second problem, same idea. Let's do my domain first. Domain is left to right. So draw your left to right line, see where your farthest left point is. The farthest left point's right here, and the farthest right point is right here. On the left, that x value is going to be -3, and the farthest right value is going to be 1, 2, 3, 4. Both of these are open circles on the left and the right, so it's gonna be a parentheses. Then do your domain inequality notation. They're just less than signs because they're open circles, and then lowest value here, highest value here. Now switch your brain around, and now we're going to go bottom to top. Okay, so very bottom point, very top point. My bottom point is right here, and that y value is 0 because it's at the point 0, 0. So my lowest y value is 0. My highest value is right here, which is at 1, 2, 3, 4, 5. Now be very careful. This 0 point has a bracket. That 0 point is a closed circle. See how it is a closed circle in the blue? But my highest point is an open circle, so that's a parentheses. Then go ahead and put it in your inequality notation, which looks like this. Okay. Last one, domain. Left to right, look for your farthest left point, which is this guy right here. Farthest right point is that guy right there. In terms of x, that x is at 1, 2, 3, 4, 5, 6. It's at -6. And farthest right is at 1, 2, 3. They're both closed circles, so that's closed brackets. And using my inequality notation, it will look like this. Now switch your brain around. Do your very lowest point to your very highest point and count where those y values are. This y value is at 1, 2, 3, 4, 5, 6. So it's at -6. And your highest y value right here is at +1. Both open circles, so we use brackets. And then when we put it in our notation, it will look like this. Okay. On all the practice problems, you're going to be required to use both notations. So I need to see both of these in all your practice problems, okay? So let's take a look at one last type of continuous graph you're going to see. They won't all be this stop and start in a line. At some point, you're going to see continuous graphs that look like this, that have these things at the end where it shows they go on forever. So many functions do not start and begin at specific points. Some continuous functions use arrows to show infinite possible points. Arrows mean that this graph goes on forever and ever and ever. So this arrow right here and this arrow right here shows that this graph would continue off the grid for infinity. It would just keep going. I know the grid only shows these points, but arrows mean it keeps going off the grid. We can't just draw a grid that's infinity. It would be ridiculous and take up so much space. So we still have to describe domain and range because we still have to describe all the possible points this graph could use. So in order to do that, we use a very special symbol that I hope that you guys know, which is this infinity symbol, this little sideways 8 guy. Okay, this is what we use to show infinity. Okay, this is your infinity symbol. And here's what this is going to look like. Okay, so domain is still the exact same idea with this left to right. So farthest left point and then farthest right point. That's how I think I draw my lines, or I put my hands on the graph and I think left to right. So domain is x values. My farthest left point is this guy right here, and that x value is 0. My farthest right point is not here and here. It's not going to be 1, 2, 3, 4, 5, 6, 7, 8. It can't be 8 because it goes on past 8. So we could have 9, 10, 11, 12 still be possible x values. So to show this, that it goes on forever and ever, we're going to say that this graph starts at 0 and goes to infinity. That's our domain. So 0 has a solid bracket because it's a solid point, but infinity doesn't stop at a point. It keeps going. So infinity always uses a parentheses. Okay. Infinity always uses parentheses. Okay, so that's our domain. It goes from 0 and it goes on forever and ever and ever to the right. So what does this mean in terms of range? Well, let's go ahead and I'm going to put these here again. Let's go ahead and talk about remember range goes from the bottom all the way to the top. So the bottom point on this graph kind of looks like this again where that arrow stops. However, the y values are going to keep going farther and farther down. So they're going to go on forever and forever down. And to show that, we say negative infinity because those are going to be all negative values of y. This graph is also going to go infinite up. So because it's going to go infinitely up, we can say, okay, it includes all positive values of y. So this range is actually negative infinity to infinity, and we use parentheses to describe that. Okay, so we use a negative when it goes left or down. This one went down. I'll show you one later that goes left. Inequality notation is exactly the same way we do it if we didn't have infinity. So we're going to put our x here. Since it's a bracket, we're going to put the little equal to sign. Since this is a parentheses, we're not. And then we're going to put infinity here. So it's exactly the same. That doesn't change. This one will be y in the middle, less than, negative infinity to infinity. Okay? Let's try the next one. The next one, again, domain is left to right. Well, to the left, it's going to keep going up, and to the right, it's going to keep going up. So this domain is going to go left and right forever and ever and ever. So it's going to go left forever, and then it's going to go right forever. Okay, sometimes infinity domain and range is way easier because if you have infinity, you just put infinity, you don't have to actually count the point. Okay, so then it's going to be x less than negative infinity to infinity. The range is a little bit different because the range, we have a stopping point, right? The range starts here and that's my lowest point. So my lowest point for my range is 0. My highest point for the range, I can't find one. The highest point is going to go up forever and ever, so my highest point is infinity. Okay, same thing here when you do your inequality. Just be careful of your symbols that you use for brackets and parentheses. Okay, we have 2 more. A straight line. A straight line has the easiest domain and range of all time. Because in a straight line, when we look at the arrows, it goes up forever and it goes to the right forever. This goes down forever and to the left forever. So domain of a straight line is always going to be negative infinity to infinity for domain and negative infinity to infinity for a range because there's no stopping point anywhere. It goes on forever and ever and ever, left and right. So domain and range for a straight line is by far the easiest thing to think about. One thing, please don't forget your negatives. It happens a lot. Don't forget these things. It's really important. Okay. Now let's look at this goofy guy. Here we've got domain. Remember, domain is left to right, so there's my left, there's my right. To the left, it goes on to negative infinity. So negative infinity are all my left points. My right point stops right here, and that's at 0. So I've got parentheses here and a bracket here for my domain. And the 0 is a bracket, so that's going to look like this with the equal to on your inequality, and it's going to be 0. Domain is very, very similar. Domain, you want your lowest point to your highest point. Well, here, your lowest point starts at 0. So our range is going to start at 0 and not end at 0. And then it's going to go to the left, or sorry, it's going to go up because range is up and down. It's going to go up to positive infinity. Okay. Domain and range is really, really challenging. I'm making it look really easy because I've done this so many times, but it really takes time to wrap your head around all of this symbols, all of this notation, and what you're looking for. This is not something I want you to do quickly. On your practice, unfortunately, I have made your boxes really small, and I'm not really easily sure how to fix that. If you want to use scrap paper to show that, or on the sides of your paper to show that, I'm totally okay. But I do need to see all of your work, and I'm going to ask you to explain some stuff too. Because it's a very critical skill. We're going to use domain and range the rest of the year. I'm going to show you graphs throughout the year, and some test questions will just randomly be, what's the domain and range? So do not take this practice lightly, okay? I know I always say that, but a lot of you still choose not to, okay? A lot of you do a great job, but I really want you to take this one seriously, all right? Please ask for help, and good luck.